data and results. Most often in data analysis, you would want to understand the kind of data that you have, and one intuitive way to learn about the data is to visualize it. In Python, there are many packages that offer good visualization tools. However, for this lesson, we will focus on Bouquet. Bouquet is an especially popular package for interactive visualization. In the next lesson, we will look at some static visuals using Seaborn. To set up, go ahead and run the first code cell. This imports Bouquet and other packages that are required for this lesson. Bouquet is designed to output HTML, which you can then embed in any website. To embed Bouquet into a Jupyter notebook, we need to do the following. Before we move on, let's talk about grammar of graphics. The grammar of graphics is an idea of Leland Wilkinson. Its basic idea is that the way most people think about visualizing data is ad hoc and unsystematic, whereas there exists in fact a formal language for describing visual displays. The reason why this idea is important and powerful in the context of our course is that it makes visualizing more systematic, thereby making it easier to create those visualizations through code. The high-level concept is quite simple. First, we start with a tidy data set. We then transform it into a new tidy data set. Later, we map variables to geometric objects like either bars, points, or lines, or any other aesthetic flourishes like as colors. We then rescale or retransform the visual coordinate system. And lastly, we render the visuals. Now that we understand the idea, let's take a look at some of the high-level charts. The easiest way to use Bouquet is to call its interface for canned charts. For instance, let's load the iris dataset and study relationships among its variables such as petal length versus petal width. The cells below demonstrate histograms, simple scatter plots, and box plots. However, there is a much larger gallery of options that you can look at in this particular link. We have now loaded our data set into a variable called flora. As we can see, the data contains 5 columns, one containing the species and the rest containing sepal length, petal width, and petal width for those species. In the next code cell, we will import the charts that we are going to be working with. As mentioned before, we will look at histogram, scatter plot, and box plot. The show function lets you visualize the charts that we create. Now that we understand the idea, let's look at some of the high-level charts. The easiest way to use Bouquet is to call its interface for canned charts. For instance, let's look the iris dataset and study relationships among its variables such as petal length versus petal width. Now the cells below demonstrate histograms, simple scatter plots, and box plots. However, there is a much larger gallery of options that you can take a look at in this particular link. Let's load the data set and store it in a variable called flora. As we can see, the data contains 5 columns, one containing the species and the rest containing sepal length, sepal width, petal length, and petal width for the species. In the next code cell, we will import the charts that we are going to be working with. As mentioned before, we will be looking at histogram, scatter plot, and box plot. The show function lets you visualize the data or the charts that you want to create. The histogram function can take a pandas data frame as input and refer to the aggregation variable by column name. The plot is interactive and comes with a bunch of tools. You can customize these tools as necessary. You can look at this link for all the available options. Let's now create a histogram that takes in the pandas data frame, flora, that we created above, and aggregated by the column petal width. This is now stored in a variable called p. We then call the function showP to visualize the histogram. Upon running this code cell, you can look at the histogram and the various tools that are present that can help you navigate through this visual. that we can plot histograms per sepal length or sepal width just by changing the aggregation variable to the required column. You can also fix the tools that you want to create by creating a list of the required options as given over here. Let's now look at how to create a scatter plot. The scatter method also takes in the pandas data frame and compares the relationship between x and y based on the columns of the data frame. In this code cell, we plot the scatter plot between petal width and the sepal length. Just like the histogram, we can plot scatter plots to understand the relationship between petal width and petal length, or sepal width and sepal length, just by changing the values of x and y in the inputs. The last one we will look at in this lesson is the box plot. Box plots are generally useful when we are trying to understand the variation in the values for a given attribute. Now in this code cell, we will look at how sepal length varies with petal width. This can be done by the function box plot. Just like others, this takes in the pandas data frame as well and requires two other inputs, that is, the values and the label that can be referred to the columns of that data frame. In our example, we are trying to understand the variation in sepal length for a given petal width. Hence, values will be sepal length and the label will be petal width. Running this code, you can visualize the plot and use the tools available to look at any specifics required. Let us now look at some variants of these plots in Bouquet. Beyond the can methods above, Bouquet provides a mid-level interface that more directly exposes the grammar of graphics methodology for constructing visual displays. The basic procedure is as follows. We first create a blank canvas by calling bouquet.plotting.figure. And then later we add glyphs, which are nothing but geometric shapes. You can also add a lot of different kind of glyphs, and you can refer to this particular link to see the available options.